Let's give an example calculation of this type of thing. So here's a problem that we answer with a line integral. We've got a vector field, f of x, y is equal to 0 of x, and we've got an object moving once counterclockwise around the unit circle. So we want to measure the total transfer of energy either to or from the vector field to the object. So the first thing we have to do is we always have to parameterize. In this case, we've got an object going around the unit circle. So we can parameterize that by saying x is equal to cos of t and y is equal to sine of t. That parameterizes moving counterclockwise around the unit circle. And to get the right amount of time, we have to say that we're going between 0 and 2 pi. That gives us a trip once counterclockwise around the unit circle. Step 1 then is we have to evaluate f of c of t. We have to evaluate our vector field at the position x comma y here. Our parameterized curve is c of t is equal to cos t comma sine t, like so. And so our vector field at c of t is given by, our vector field is always 0 comma x, and x is cos t, like so. The second thing we have to calculate is we have to calculate c prime of t. We have to calculate the velocity vector. In this case, c prime of t is equal to the derivative of cos is minus sine, and the derivative of sine is cos. Then we have to take the dot product of those two. To take the dot product, here we're taking the dot product of the vector 0 comma cos t with this formula for the velocity vector minus sine t comma cos t. That dot product is 0 times minus sine t plus cos t times cos t. And that just, first part goes away and we're just left with cos squared t. That's our dot product. And then finally, at the end of the day, we integrate. We're integrating this function that we got, cos squared t. And when we integrate cos squared t, we're going to be integrating it from 0 to 2 pi because that was the time that we were parameterizing to go once around the unit circle. And then I could do that integral I want for this particular, and dt. For this particular integral, what I would do is I would use a double angular formula to say that cos squared t is 1 plus cos of 2t divided by 2, and then go on from there. But the integral is more mechanical. We've already seen it in earlier calculus courses. And so this is how we do the calculation. And this sequence of steps is always what we need. We need to parameterize, we need to plug in, we need to find velocity, we need to calculate this dot product, and then we need to do the integration. And that's it.